So B+Tree and DBMS considerations. Take a sip of tea, take a sip of coffee, relax a little bit. I know it's a long video, guys, but I think we need to discuss these in details. You can pause the video and come back later. It's all right, right? This is there's a lot of content there. Ask me questions, ask questions as you encounter them. But this is very, very interesting to understand now. So B+Trees and DBMS considerations. There's an additional cost here, which is the leaf pointer. Again, for instance, MySQL, InnoDB, and Postgres, SQL Server all have these leaf pointers that points to the next of the next leaf point in the B+Tree leaf nodes. Wired Tiger in MongoDB. Yes, MongoDB does use B+Trees through this Wired Tiger database engine, which I have a lecture about database engines, right? Talk about that. And Wired Tiger is a B+Tree based engine, and also they have an LSM variant, log structure merge tree, that doesn't have this pointer, right? For design decisions, those guys are smart. They only include things where they absolutely need it. So it's like, okay, range queries, who cares? You're not gonna do a range queries in Mongo, for instance. Okay, you're not gonna search for range of keys. Don't do that, right? One node fits a DBMS page, as I discussed. Most DBMSs do that. Can also fit internal nodes easily in memory for fast traversal, because the nodes are now tinier, I guess, right? You can fit a lot of elements, right, in these internal nodes. You can fit these internal nodes in memory easier. So the traversal, a single IO will give you way more elements. As a result, it's way faster, right? Plus, these again really depends on what are you indexing on. This can fit in memory. If it's a GUID or UID, it's not as easy to fit in memory, but still can. Usually the internal nodes is not as busy as the leaf nodes in a B+Trees. Leaf nodes can live in the data files in the heap. That's absolutely fine. It is obviously you can try to put them in memory, but if the values, right, the value that points to is expensive, then sometimes it's not possible. Most DBMS uses B+Trees. So here's an example of the storage cost here. This really, I said should between quotes here, but doesn't have to, right? The B-tree index works best when it's in memory, right? So when you load up your database, let's say you have a table with 5 indexes, you can try to put all the indexes in memory, and you can check the sizes of the indexes by doing a query on the database and see, can I fit this entire index in memory? Most of the times the indexes are tiny, like if you don't have large files. But if it's large, some databases make the choice, okay, I'm gonna only put the internal nodes in memory so that my traversals are so fast, because I cache the page, and these are tiny, right? And not necessarily tiny, because these are pages the same size, but I have way more elements, and as a result I can traverse way more. And this could fit in disk, but you can definitely put it in memory. Nothing that stops you from doing that, right? If they fit. Again, it really depends on this pointer, and also depends on what you're keying on, right?